Good morning, students. So, in today's lecture, we will complete the animation part, and from the next lecture onwards, we will go for gaming and Unit 6 day after. So, those who have joined the meeting, type your complete seat number and roll number and name. Okay, so let's start. In computer animation, we saw last lectures the definition of computer animation. It is the art of creating moving images via the use of computers, its applications, and keyframe animations. What do you mean by keyframe animations? Then we started with the animation sequences, story of animation, layout. So these are the steps in designing animation sequence. Before that, we have started with the animation sequences and conventional animation, storyboard, keyframes, in between frames. So we completed up to in between frames. So this is storyboard layout. With the help of sequence of sketches, the ideas and of structure animation is created. This is, you can say, outline form of animation, which we called it as a storyboard layout, which is explained with this 6 keyframes. Next, we are having object definition in the scene. Which are the objects present? What are the shapes of that object? What are the motion associated with that object? How and which part of that object is visible, not visible? Any transformation which we are going to apply on that object. That is, we are going to decide in the next step, that is object definition. Then next, we are having very important keyframes drawing. So mainly there are main frames, which we call it as a keyframe, and then to run it with the speed of 24 frames per second for generating a film, we required in between frames. So there is one more sub point, generation of that in between frame. Once the frames in animation are decided and it is the main frames, we called it as that frames as keyframe animation. Then we are having in between frame. The animation are drawn with the help of keyframes, and the intermediate position between the keyframes, we called it as a in between frames. So here one example is given, and this in between frame mostly generated automatically also. So the software which we are using for generating animation, it's responsibility of that software to generate the in between keyframes. Many times animator also generate it by its own. Then after this, we are having, after in between frames, we are having few more steps left, that are pencil test. So with the help of keyframes and in between frames, you are going to generate one trial film, a trial animation, and you are going to run it from start to end. That is called as pencil test. Cells, we are going to fix the frames, in between frames, all frames, and we are going to decide, we are going to draw it on celluloid sheets so that it is going to run from start to end. So that is process, which is a common technique to decompose an animation picture into several parts that can move more or less independently, which we call it as a cells. These parts are drawn individually. Cells can be overlaid to produce the whole animation. to produce the whole picture and then filmed or video recorded as one frame. So that allows to make sequence of pictures with changes in the picture by appropriately moving the individual cells. That is, we call it as a cells. Next, we are having rod sheet. The sheet which describes each scene and the people responsible for the various aspects of producing the scene. That is called as root sheet. Let's say in one example, one scene, we required some sound, we required some lights, we required some in-between and keyframes. So that all information of that one scene we are going to store. And that is, we call it as a root sheet. Then after root sheet, we are having last sequence in generating animation, that is exposure sheet. What we are having in exposure sheet, instead of root sheet we are having one scene information stored. In exposure sheet, we are going to store information of all the scenes, all the steps. So the sheet which is an immensely detailed description of animation, that which sound is going to play at which time, the first frame to last frame, each and every detailed descriptions of animation is stored in the exposure sheet. So that we called it as export sheet. It gives details for each frame, such as order of all the figures in the frame, dialogue description, any sound required, choice of background, camera position within the frame, all that is given in the exposure sheet. So that is all about the steps in design of animation sequence. So we can explain the steps in 7 to 8 lines here. That is, first, the story of animation is written and a storyboard is created, just like a comic book. Start to end, we are going to decide the each frames, design the each frames, which tells us the story, whole story of animation. If any soundtrack is required according to the drawing for every scenes, then that soundtrack is decided. The detailed layout of that procedure is decided in sound recording. The instance at which significant sounds occur are recorded in order. Then the detailed layout and the soundtracks are correlated. The next step, we are having drawing certain keyframes, which we decided in our storyboard. So drawing, deciding that keyframes. With the keyframes, next we are going to generate obviously the in-between frames. And then with the help of keyframes, in-between frames, the sound order we have decided, we are going to run it. We are going to trial run it with the help of pencil test. So the pencil test frames are then transferred to cells. This is done either by hand copying in ink or by photocopying directly onto the cells. The cells are then colored if required and painted and arranged in a correct sequence, and then accordingly it is filled, it is decided for the animation. So this multi-line animation, some layers of cells are used for background and some for foreground characters. The background cells remains constant except for a translation. Foreground cells that where we require translation, that need to change over the time. The next, since the animation uses keyframes and in-between frames, we call this animation as keyframe animation. So that are the steps and animation sequences required so far. Now next move toward the next point, that is computer-based animation. Question can be asked on this: what is computer-based animation? Okay, there are only, I think, 46 participants right now, and in the chat section we are having 27. Okay, those who are not typed their roll number and name yet, just type it in the chat section so that your attendance will be marked. So computer-based animation, it is created with a computer and animation software. Some examples of computer-based animation software are Art of Illusion, 3D Studio Max, Adobe Flash Player, Windows Movie Maker. With the help of that, which you can create computer-based animation. This software provides basic functions to create an animation and to process individual objects like transformation. The functions are also available to store and manipulate object database, motion generation, object rendering, any transformation if needed. In object database, object shapes and associated parameters are stored, and they are updated as and when we proceed with the animation. Let us see the steps, basic steps needed in computer generated animation. The first one is digitization, composition, in between frames, equivalent pencil test, and generation of that in between frames. So generation of in between frames, pencil test, that we already saw in the previous slides. The new things here are digitization and composition. So what is digitization? Before using the computer for animation, the drawings are drawn with the help of hand, and that drawings, the decomposite parts, must be digitized. So that can be done by using methods like producing original drawings by animation in paint systems. So whatever we are drawn, we are going to draw same kind of thing in the paint, or we are going to scan it. Just scan all the pictures, all the frames. By tracking the drawings with the data tablet, or you can track the drawings with data tablet. So the resulting drawings may need further processing, such as filtering to clean up the bleaches if there are any. We can also smooth the contours in the drawings. So that is all part related to digitization. Second part we are having here is composition. What we are having composition, that individual keyframes are generated with proper combination of cells. The foreground and the background figures are also combined using image composition techniques, which produces your final keyframes. So that is the main part, composition of this keyframes. Then we are having in between frames. Animation softwares allows us to generate in between frames, so that will automatically get generated by the software. These are the intermediate frames between the keyframes. Usually there are 3 to 5, you can say, in between two keyframes. Between two keyframes there are 3 to 5 intermediate or in between keyframes. Suppose we want to design an animation sequence for 10 seconds. And for this we need to have how many frames? For 1 second we require 24 frames. So for 10 frames we require 24 into 10 frames. So because films require 24 frames per second, we require each second 24 frames. So out of this 240 frames, we can have 48 keyframes, and remaining all 192 keyframes are called as in-between keyframes, which can be generated by softwares. So in this case, there are 4 in-between frames between 2 keyframes. If you take an example of 10 seconds, so that you can explain there. The generation of this in-between frames, we have to generate this by using the softwares which we are using, by using 2 or more keyframes. Or this in-between frames are generated with the knowledge of motion that object is going to carry out. We can specify motion details as follows. Motion paths can be specified with a kinematic description as a set of spline curves, or the forces acting on the objects can be specified. Let's say a ball is getting thrown from one person to another person, so there we need to maintain one arc. So there we can generate that in between frames. In case of complex scenes, the frames are divided into individual components or objects called cells that highlight transparency. Then in between frames of individual objects are generated using interpolation many times, and complex transformations in which shape of object may change. So the transformation we already saw. So for example, in object like cloth, facial features, the shape of the object may change. If such object is specified with polygon meshes, then the number of edges are per polygon which are going to change from one frame to another frame. That with the help of that you can generate the in-between keyframes. We are having equivalent of pencil test. A rectangular array is taken and several small resolution frames of an animation are placed in it. In a frame buffer, a particular portion of such a low resolution image, typically 1/25th or 1/26th, is typically what we are going to take. This portion is moved to the center of the screen, which is called as panning. So that we already saw with the video of types of animation. Then using zooming techniques, this portion is enlarged so as to fill the entire screen. The same portion is repeated on the several films of the animation which are stored, and that are stored in an array for the single image. If these steps are carried out fast enough so that it is not recognized by human eye, the effect of continuity is observed, and since each frame of the animation is reduced to a very small part of the total image, typically 1/25th or 1/36th, and then it is expanded to fill the complete screen. So this is what the process of effectively lowering the display device resolution, which we call it as equivalent of pencil test. So this is all are the steps of computer generated animation: digitization, composition, then in between frames, generation of that in between frames, and lastly equivalent of pencil test. Next we are having methods of controlling this animation. So controlling an animation is not depending on the language used for describing it. There are special methods or functions used for controlling animation. First, we are having full explicit control, then procedural control, constraint-based system, tracking live section, actors, kinematics and dynamics, and physically based animation. Full explicit control is the simplest sort of animation control. Here as the name suggests, the animator provide detailed description of everything that is going to happen in animation. This includes the information about scaling, translation, rotation, keyframes, interpolation methods for generating the in-between frames. Everything is in detail described. In this system, a sequence of actions defined between keyframes may be difficult to modify. Extending one action may require shortening the neighboring actions to preserve the coherence of the animation. For example, consider an animation in which one ball rolls up and hits another, causing the second ball to roll away. So if the first ball is made to move more quickly, the start of the second action, that is the second ball rolling away, must start early. Like this detailed description is specified, that method of controlling animation, we call it as full explicit control. Next, we are having procedural control. So what is procedural control? In this control, various methods, various elements of the model communicate each other in order to determine their properties. Such control is ideally suited in controlling the animation. For example, we can animate the position of grass blades according to wind flow. In such animation, wind particles are involved to determine the position of the grass blades. So, in the direction of wind, your grass blades are supposed to move. So that is the procedural control. Thus, the particle system describing the grass was affected by aspects of other objects in the scene. This sort of procedural interaction, we call it as controlling method, which is we call it as procedural controlling method. Then we are having constraint-based system. Constraint stands for one rule or condition. So the motion of the object is modeled by this constraint. Let's say for rigid or hard or iron ball, we are not going to apply squash and stretch. But a soft rubber ball, we are going to apply their squash and stretch. So like this constraint is going to control our animation. Next, we are having tracking live action. In this, animation is created by replacing the human actors with their animation equivalent. The technique provides realistic motion. Most of the movies we saw it where for controlling or getting the actions expression of the animator character, we are going to use that expressions. First we are going to get from human actor and then we are going to map it on our character. Next we are having actors. So a high level form of procedural control. Here actor means you can say a small program which is invoked per frame to determine the characteristics of some objects in the animation. So that is actors. Next we are having kinematics and dynamics. In this, the position and velocities of points are described and the physics laws that govern that kinematics or dynamics are considered to control the motion of objects. So strictly as per that laws of physics, we are going to decide that particular object movement. And last, we are having physical based animation, where physical based models are going to simulate the actions. So the evolution of physical systems are used to control the motion of objects. It is also used in many of the movies. The whole physical body of humans is captured and then it is applied to our animation. So that all are about the methods of controlling animation. Next, we are having some guidelines for this animation. So the brief guidelines of animation can explain is as like this, where we are having illustration, then effect, then relationship, transition, and feedback. So as these techniques of animation developed, some basic principles evolved that became the fundamental rules for character animation and are still widely used today also. Despite their origins in cartoon character animation, many of them apply equally to realistic 3D animations. We are going to discuss this all few guidelines of animation. First one is illustration. It means animations communicate information visually instead of verbally. So many of the times in cartoon movies you see that if that characters are not doing anything, still they are somewhat moving. That showing their liveness of the thing. If that objects are not going to move at all, it is going to be steady, it is going to generate somewhat bore effect or somewhat steady effect, which does not suits to the animation. So there must be always this illustration, that communication through visual. Next, we are having effect. Animation create interactions to models, their real world counterparts. So we are going to always give some effect to our animation, which suits or which looks like in real world. Next, relationship. So animation show relationships between objects, where objects come from, where it is going to, where it is stuck up, where it is damaged, it is going to break, all these kind of relationships that you are going to show in animation. Transition shows major user interface, that is transitions like translation, scaling, rotation. We are going to translate one particular object, scale particular object, big or small. Like this, many transitions we can apply. So that is nothing but changing state from one to another. And lastly, feedback. Animations show that something is being done correctly or incorrectly, or show processing or some progress. So that is what you are having feedback. So the human eye is sensitive to motion, especially peripheral motion. If you use animation to draw attention to something, make sure that attention is well deserved and worthy of interpretation. Animations don't have to demand attentions to be successful. In fact, many successful animations are so natural that users are not even aware of them. There are certain do's and don'ts for good animation that we will see. So illustration animations means we have to always visually interact with the audience. Show one thing at a time to avoid overwhelming users. Play at the optimal speed, not so fast, not so slow. Gradually increase the speed of repeated animations. Viewers will already be familiar with the animation, so increasing speed slowly will feel right. Use timing to emphasize importance, such as slowing down for important parts. That is all about illustrations. Next, effect animations. Use effect animations for object that the user is currently interacting with. Such animations are not distracting because the user is already focused on the object. Minimum use of effect animation that show status. Make sure they have real value by providing additional information to users that can actually use. Examples include in transient status changes and emergencies. They are short in duration and therefore not running most of the time. They can be turned off. So that is what all about effect. Keep effect animation low key so that don't draw too much attention to themselves. Next, you are having relationship animations. Must start or end with the selected object. Don't show relationships between object the user is currently interacting with. Must complete with a half second or less. Transition animations used to show relationship between states. Animating state change make them easier to understand and appear smoother. Make sure that transitions have natural mappings. For example, an opening window transition should be upward and expand. A closing window transition should be downward and contract. So like this, you can have transition animations which also going to complete within half second or less. There are certain don'ts. We can add feedback animations also, that is clearly identifiable completion and failure states. Must stop showing progress when the underlying process is not making progress. Don'ts don't use animations that can noticeably affect performance. Consider performance over slow network connections or when many objects are involved. Don't draw attention to things that are not worthy for attention. So for critical animations, there are many more guidelines. Many times we have to give priority to visualizations than to strict rules. Use of color is often very important and must be chosen properly. The timing of animation is often driven by computing time instead of by final appearance. A lot of much time is possible to artistic consideration in the generation of animation. Overall filling in animation is very important aspect. So that is all about do's and don'ts of animation. Last point here, we are having animation languages. So there are many different languages and these are broadly categorized into these three. First one, linear list notation, then general purpose languages, then graphical languages. Linear notations, each event in the animation is described by starting and ending frame number and an action that is to take place. A typical statement will be of 20, 40 to 60 frames. Means between 20 to 40, rotate the object about its axis by 1 or 60 degrees and determining the amount of rotation at which frame is rotating. So that is all about linear list notations. Second, we are having general purpose language. So we are running out of time. So general purpose programming language, mostly you see C++, Lisp, that also where we can design the languages. Graphical languages are also there, which we will see in next lecture. So I think you have marked, all of you mark the attendance in the chat section, right? We are remaining with the computer animation languages and motion specification methods. So we'll complete these 2 points in next session and then we will move towards the last part of Unit 5, that is gaming. So this is all for today's session. Thank you for attending it. Stay at home, stay safe.